If this is the first time you're watching my video, well, welcome dear viewer. This is a series where I take a look at one of the flat earth flyer and discuss/debunk one section at a time. So far we covered water is a natural level, airplane level flights, science says is stationary, horizon is always eye level, we see too far, dome is real, moonlight is cold and crepuscular sun rays. This video is all about gravity is magic. Newton's theory has never been proven. Gravity is easily explained by density and buoyancy. Things rise or fall based on their density and the medium in which they are traveling through. Format of this video. First half we will be discussing this paragraph itself. Once that's done, we will take a look at one of their document which tries a bit harder. Let's start with objects' basic properties. First we have is volume, the space an object occupies, where mass is the physical property that determines its resistance to being accelerated, or the force of gravitational attraction with another body. Finally, density is the physical property which defines the amount of mass within a physical volume. To understand the relationship, imagine a Rubik's Cube. As the name suggests, it's a cube. Suppose it has a mass of m and the space it occupies is v and density is p. Density p simply equals to mass m divided by volume v. Now if you could squeeze it and say make it half its original size, i.e. make it half as wide as before, well, the mass remains the same. The volume is now 1/8 of what it was before, thus it's now 8 times more denser than what it was. Similarly, if we could expand it, the mass would stay same, volume would increase and density would decrease. As long as no energy or matter is added to the object, its mass will always remain the same. Density is really a relationship between mass and volume, and this volume can change depending on external forces. That Rubik's Cube was just to illustrate that relation. In real life, well, if you have been on a train, you must have heard that clickety-clack sound it makes. That happens when the wheels go over a gap in the track. That gap is there to compensate for the track expanding due to the heat. That itself is a super fun and complicated math. That section of track, in this case, has the same mass, but it expanded due to heat and thus increasing its volume. This long explanation of properties was really to point out one thing. They don't have any direction. Now one can argue about the molecules, but then I would argue then it's in every direction and stop being so pedantic. Whereas when we talk about forces, well, forces are vector. Wait, this is going to sound fishy. We agnostics argue that religious people cannot use their holy book to prove their holy book. There's a beautiful word to describe it, but for the love of God, I can't recall it as I'm writing the script. Here we're talking about Newton's law of universal gravitation, and I'm about to reference Sir Newton's law of motion. Damn. Well, following is not the great example, but this is the best I can come up with. Suppose Pythagoras' theory of proportion was based on his Pythagorean theorem. It's not, but just suppose. Now, would it be wrong for me to use the theorem, knowing that it has been proven countless times by different methods by many different mathematicians? Of course not. Similarly, countless physicists have verified Newton's law. They have filled in some gaps. More theories were devised from it. Looking at you, Albert Einstein. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. The second law explains how the velocity of an object changes when it is subjected to an external force. Back to force and being a vector. Let's not confuse it with a biological vector. In mathematics, vector is a quantity having direction as well as magnitude. So when you throw a ball towards the sky, we're applying a force with a direction. It has a mass and it accelerates. But what happens when we simply let go of the ball? It drops. So for it to have an acceleration from a rest position means there has to be a force acting on it. Otherwise, it would remain still and floating. For the thrown ball, as the initial force is no longer applied, that ball starts losing its acceleration. And once there is no acceleration and velocity, well, back to rest position and it starts to drop. Now, it cannot be density, as density is not a force, it's a property. Now, buoyancy is an upward force exerted by a fluid that opposes the weight of a partially or a fully immersed object. So at least it's a vector. That's a good start. But doesn't that bring some other issues? When we say upward force, that up is established from down, which is the gravity pulling it towards Earth's center. If there is no gravity, then there is no reference to upward force. Supposing the fluid here is air, and that is the buoyancy force. Okay, but without gravity, there is no down. So why does my ball fall down and doesn't go sideways? Next, we have tested dropping a feather and a bowling ball in complete vacuum. Well, as vacuum as we could get. Spoiler, both items fell at the same rate. A vacuum, well, there is no stuff there, nothing. So what is the medium there that exerts a force? And again, if there was a fluid, how does it know to fall down? Finally, if density was the reason, then why did they reach the bottom at the same time? The statement, gravity is easily explained by density and buoyancy, please do explain. So why did the ball drop? Well, a force acts on it, which acts even in a vacuum, and didn't really depend on the density and stuff. And this force acts downwards. We call this force gravity. This value g, which is 9.8 meters per square second at sea level on the Earth. All this finally brings us to weight. That is a funny beast. In science and engineering, the weight of an object is the force acting on the object due to gravity. Others define weight as a scalar quantity. In day-to-day conversation, when we talk about weight, we really think of it as a scalar and measure it in kilogram, pounds and so on. Where in physics, it would be measured in Newton. But either way, in simple term, we just multiply the mass by 9.8 to get the weight in same unit. So something with 1 kilogram in mass, well, at sea level, it would weigh 9.8 kilogram. But if we take the same item to Moon, where the gravity pull is about 1/6 of Earth, it would only weigh around 1.63 kilogram. But can we prove it without going to Moon? Glad you asked. Gravity is a very weak force, and the higher we move away, the lower it is. Which means that 9.8 per square second at sea level, well, if you go on top of a mountain, in theory, it should be lower, which means you should weigh less at the top of a mountain compared to sea level, right? Yes, correct. That is exactly what we see. By one estimate, a person who weighs 150 pounds on the surface of the Earth would weigh approximately 149.92 pounds at 10,000 feet above sea level. So it is measurable, but just don't expect a 10 kilo change. Newton's theory has never been proven. Yes, that is correct. I'm beginning to see how these flat earthers manage to spread. With a simple yes or no answer, some of their statement is often correct. Gravity is what we call that force which causes objects to accelerate towards each other when they are otherwise left to their own devices. And the proof is the demonstration itself. From simply dropping the ball to being more careful and eliminating other effects, for instance, performing the experiment in vacuum. We can go for some Cavendish type setup. We can talk about Newtonian gravitation and Einsteinian gravity. But that would be beyond the scope of this video. However, there are no absolute proofs of these theories, only demonstrations that they are the best and simplest models that account for the known facts of nature and have predictive utility. One user in Quora puts it very eloquently. There is no way to absolutely rule out the idea that gravity is caused by invisible, insubstantial pixies that have an obsession with everything having to be as close together as possible. It's just that this model postulates something in addition to what we observe, the pixies, that are not currently needed, and we have this thing called Occam's razor. Well, that was all for this section. If you have enjoyed it so far, why not keep watching? One of their websites provides a document by the famous Eric Dubay titled Gravity Does Not Exist. It is a long-ass document with lots of fluff. It almost broke me reading it. I will not subject you to that kind of torment. Personally, I think the article raises some good points for most people. 1. Why doesn't the sun suck the earth into it, especially when it is closest to the earth? 2. Why don't we get sucked into space due to Earth's speed and rotation? 3. How come Moon's gravity impact Earth's tide, knowing the Earth's gravity is stronger, and thus nothing should have happened? And how come it doesn't affect ponds, lakes, and so on? Many people I personally know in real life wouldn't be able to answer all three satisfactorily. It is not a dig, it's just something I wasn't taught in school in great details either. Let's start way back. We believe Earth was born from a ring of materials that were moving around the Sun on a stable orbit. So after the debris coagulated to form the Earth, this initial orbital energy was retained. Hence, the Earth is moving on a stable orbit. Now the Earth is always being pulled toward the Sun by gravity. And if the Earth was stationary compared to the Sun, it would fall into the Sun under the force. But thankfully, we are moving fast enough so we are not pulled into the Sun. At the same time, we are not moving fast enough to escape the Sun's pull. In super simple terms, thus it keeps going around and around. Think of a tether ball, where the pole is the Sun and the ball is the Earth. The string in between is like the force of gravity. When you apply force to the ball, even at a great angle compared to the string, the ball still rotates around the pole. That's it. We got an orbit. Next, why don't we fly off the Earth? Earth spins at a velocity of 1670 km per hour at the equator. So someone standing at equator is in a way moving at that high speed. But because our atmosphere moves along at the same speed, we don't feel it. The same way we don't really feel the speed while sitting inside a moving car. But why don't we fly off? Often at this point, they would show us photo of a merry-go-round and how its centrifugal force, as it spins, tries to throw us off it. Well, let us compare these two. Earth rotates once per 24 hours. Now imagine sitting on a roundabout and having someone rotate it once over a day. It will be a boring ride to start with, and if you have your eyes closed, you couldn't even feel it. Next, from merry-go-rounds I remember from my childhood, I would say it took around 20 seconds to make a full rotation. So that is 3 rotations per minute. That makes it 4,320 rotations per day. But we still see all kids still on the merry-go-round, holding onto a small pole with their tiny hands and not flying off the ride. I talked about escape velocity in one of the other debunking videos. In essence, it's about 11.2 km per second at equator. Now, knowing Earth's speed at equator, distance of surface from center and so on, unless my quick calculation is wrong, Earth needs to rotate 24.18 times a day to have enough speed for our escape velocity. Aren't we lucky? Finally, tide. Oh, this is a hard one. To explain tide on its own, it can be a 15 minutes video. So I will summarize a lot. If there is ever any demand, I will make a video on tides only, I promise. Till then, first, what is tide? And what do we mean by tide comes in, tide goes out? Well, tides are the rise and fall of sea levels. Couple of misconceptions we normally have. First, tide does not come in or go out. Instead, we move into the high or low water or move out of it. Second, it's not only the moon's gravity that causes tide. Shocker, right? The sun and the rotation of Earth has something to say as well. And third, moon phase has nothing to do with anything. Because so many different variables comes into play, let's look at one at a time and finally we can try to comprehend the full picture. Flat earthers assume Earth's stronger gravity would nullify moon's gravity. Well, let's approach it in a different way. Earth with its gravity is keeping the ocean in place, in what flat earthers like to call level. Say that is the rest position. Now, when you bring another object with gravity pull, well, something should happen to the water, right? Exactly. And that is what happens. The water, in a way, bulges towards the pull. Our sun is doing the exact same thing. On the screen, you can see two bulges from these two pulls. Now, let's ignore everything else and just think about our rotation. As Earth rotates around its own axis, we are moving through these bulges. Tide comes in, tide goes out. Then think about the moon. As it is orbiting around the Earth, well, if nothing else was happening, now the bulges would be at top in our illustration. Then if you think the sun perpendicular to the moon, now we have two bulges coming together to make a different bulge. To make it even more complicated, Earth's rotation speed is a little bit faster than moon's speed, which means Earth is trying to rotate with this water shape, but the moon, lagging a bit behind, is trying to pull onto it. Because this whole tide is a dance between gravities and push rather than pull, moon phase has nothing to do with it. It just happens to be that sun and moon is at the same line during full moon and new moon, and that gives the most deviation between the bulges. At any given point on Earth, the moon's gravity is about 10 millionth times weaker than our planet's own gravitational force. But still, each drop of water on Earth is indeed pulled by the moon's gravity. And that includes lakes, ponds, and so on. But this effect isn't noticeable on a molecular level since Earth's inward pull is overpowering. But when it comes to ocean, well, it covers about 71% of Earth's surface and is connected as one liquid body. This allows the small force of each water molecule to collectively add up. Molecules of water near Earth's pole are pulled mostly straight down towards the planet's center of gravity, and the molecules closest to the moon at Earth's equator experience the strongest pull towards the moon. Since water molecules can easily move and bump into one another, these countless tiny nudges adds up and squeeze seawater away from the poles. This global water pressure works against Earth's gravity to form the bulges. These high tide bulges stay put as Earth rotates underneath them every 24 hours, leading to a tide change every 6 hours. Low tides occur where the disruption caused by tidal force is weakest and water pressure caused by Earth's gravity is strongest. Hope that explains the tide. Well, that's all for this video. Thank you so much for watching. If you have enjoyed this content, well, a like and a comment won't go amiss. If you also subscribe for future contents like this, it would definitely help my small channel grow and would be thoroughly appreciated. Have a safe day. Signing off.
Try.